To another video of Math Magic with Jen. And today we're going to be doing discovering primes. So this is a different part of Unit 4. Unit 4 started with ratios and rates, but for the next 3 sections, we're going to look at prime numbers and some number theory, basically. So the first one we're going to check out is, what is a prime number? So about a third of the way through 4th grade, students will discover what a prime number is, and I do mean discover. Okay, I'm going to walk you through that discovery, but before we get there, I have to first define a couple vocabulary terms. So if you have a number p, so any number, then any pair of whole numbers that multiply to p are called factors of p. So for example, you can get 12 by taking 1 times 12. You can also get it by 2 times 6 and 6 times 2, although order here doesn't matter. So if you have 2 times 6, you don't need to write 6 times 2. They're the same. And then you also have 3 times 4. So it turns out that each pair are factors. So 1, 12, 2, 6, 3, and 4 are all factors of 12. And here I have them all listed. So any pair of whole numbers that multiply to another number is a factor of that number. If you have a number p, then 1 times p, 2 times p, 3 times p are called multiples of p. So for example, if we want to look at multiples of 6, 1 times 6 is 6, 2 times 6 is 12, 3 times 6 is 18. So 6, 12, 18, 24, 30, these are all multiples of 6. So now, I have to say that when I think of multiples, I also just think of counting by 6. So if I want to find multiples of 7, I'd want to count by 7. So 7, 14, 21, 28. Now, it's also easier to count by these things if you know your multiplication times table facts. So you could also think of multiples as times table facts. So these are all the times tables facts for 6. What I was quoting earlier was all the times tables facts for 7. So we're going to try one of these real quick because we do need factors and multiples before we can talk about primes. Okay, so let's say I want to find all the factors of 30. Okay, so what you can do is you can just ask students for pairs, right? I need all the pairs that multiply to 30. But the trick is, how do you know if you got all the pairs, right? So I'm going to show you a little hack that I learned, which is you start with the number 1, you go to the number 2, 3, 4, 5, 6, and you take this list as far down as you need, okay? So we ask our students, 1 times what gets us to 30? 1 times 30, so there's our first pair. Then we say, well, 2 does 2 times something equal 30? Yep, 15. All right, how about 3? 3 times 10 gets me to 30. Okay, now this one's going to stump them. 4. 4 times something gets me to 30. No. 4 times 7 is 28. 4 times 8 is 32. So even though I wrote a 4 here, this is like a checklist. I'm going through all the numbers, 1, 2, 3, and I'm going to go over here to 5, okay? And 5 times 6 gets me to 30. And here's the beautiful part. You know you found them all if you hit this number at any point past this one. So for example, even if it wasn't just the next digit down, if it was 2 or 3 digits down, the second that we start to repeat our list, we're done. So these are all the factors of 30. Now, what I really love about this list, if I come over here and clean it up a little bit, is that if you go up, actually down, and then up, you'll get them in numerical order. So 1, 2, 3, 5, 6, 10, 15, and 30. Okay. Awesome. So tempted to do another one really quick. Well, should I? Oh man. Okay. If we want to do something like, let's say 18. So 18 doesn't have that many factors, but the idea being that we go 1, 2, 3, 4, 5, 6, 7, and I mean, this could be extended. So you would have it as long as you need. Okay, so 18 would be 1 times 18. 2 would be 2 times 9. 3 is 3 times 6. 4 doesn't work. 5 doesn't work. And now we've got what's already on our list. So that's how I know my list is complete. So I just wanted to show you how you know to stop. Okay, got that one done. All right, now let's talk about the multiples of 8. So this would be, so there's 3 ways really you can do it. You can count by 8. You could think of your multiplication facts by 8, or you could literally have students do 1 times 8, 2 times 8, 3 times 8, 4 times 8, 5 times 8. That'll get you the first 5 multiples of 8. So here would be 8, 16, 24, 32, and 40. So those are the first, 5 multiplication facts of 8. So there you go. If we want the next one, we could go to the next one. All right, so why do we need factors and multiples? Okay, prime number is a number that only has 1 and itself as factors. So if I had the number 11 and I asked what are all the factors of 11, like I did on the previous slide, we'd get 1 times 11, and that's it. Okay. So super short list. So when you only have 1 in itself as factors, that's a prime number. Now, if you're not prime, so let's say we had something like the number 15. 15, yes, 15 is 1 times 15, but it's also 3 times 5. So the fact that there is another pair other than 1 in itself means it's not prime, and a fancy name for not prime is a composite number. I'm not offended if you just call it not prime, but technically the name is composite. Okay, so now, how the heck are 4th graders going to discover primes? Okay, I knew you wanted to know, or you didn't realize you wanted to know, but you're going to know anyway. Here it is. Okay, so this is in the Common Core textbook. They have this grid from 1 to 100, and they have very specific directions. Okay, so I'm going to walk you through this process. We're not going to do the whole thing because it does take quite a bit of time. But what happens is that step 1 is shade the number 1 red. Why they choose red? I have no. So if you wanted to have students choose a different color, great, but we're gonna shade that 1 red. And then it says circle the first unmarked number. You will start with 2. Love that. Cross off every multiple of that number except the one you circled. Okay. So it's asking me to cross off all multiples of 2. So 2, 4, 6, 8, 10. Okay, and you keep going. And so what's going to happen is you're going to end up basically crossing off half the numbers on this list. Ooh, okay, half the numbers on this list. Okay. What's supposed to happen is once you do this, you repeat steps 2 and 3 until every number is either circled or crossed off. So the next, after you've crossed off all the 2s, you'd go circle 3, cross off all the multiples of 3. So I'm going to show this on the next couple slides. Kind of think of it as a time-lapse photography. Okay. So just so you know, there is a Math Learning Center free app. I love the mathlearningcenter.org. They have great free apps. So they do have a number chart. So let me show you what it looks like. It looks like that. And you can actually stamp and circle and all that kind of stuff. And it does have a pretty cool feature where you can basically have it stamp every 2 or stamp every 3 or stamp every 4. So it makes this process go a little bit faster. So play with it if you want to check it out. It's optional. I'm never going to ask you, because how am I going to track you down? But you'll never have to actually create this. Well, I was going to say my students who are taking my courses will never have to do this whole process from beginning to end. But play around with this website if you find it interesting. But let me show you what happens. That's the results from crossing off 2. Now, technically, I accidentally crossed off 2, but it's also circled. So we're going to focus on the fact that it's circled. Okay. Now we're going to do it again. We're going to circle 3 and cross off multiples of 3. And then we're going to circle 5 and cross off multiples of 5. And what you're noticing is very rapidly things start getting crossed off. Okay. So then the next one would be circling 7 and crossing off multiples of 7. And then the next one would be circling 11 and crossing off multiples of 11. And so what ends up happening as you go through all of these steps is you get, not that, there we go. Okay. Okay, so that's the final result that you'll get if you're able to make it to the end. All right, so let me go back a slide to talk about what's going on here. So what students are doing is they're practicing multiples, okay? But what they're really doing is figuring out that the things that survive, so everything that is circled is going to end up being a prime number. And everything that gets crossed off was a multiple of another. So if you got crossed off, you had to be a multiple of something. So that means there was something else that divides into you, not just one and yourself. So for example, 22 is not prime because it got crossed off during the 11s because 2 times 11 is 22. Okay. 35 is not prime because it got crossed off in the multiples of 5 because 7 times 5 is 35. Okay. So what happens is you get this lovely picture. It is called, and I'm going to try my best to pronounce this right, the sieve of Eratosthenes. So Eratosthenes of Cyrene was a Greek mathematician, geographer, poet, astronomer. He was like the original Renaissance man, but way, way back in history, like way, way, way ancient Greek. And here he was also the librarian at the Library of Alexandria, which is pretty stinking cool. So I bring this up because the students are going through this process to discover what a prime number is. And so what happens, again, on my next slide, it'll say this, is that every circled number is prime. If you were crossed off, you had to be a multiple of a prime number. So you had to be divisible by something else. Okay. So here's what I like about this method. It gets students thinking big picture about how numbers relate to one another. Like it's kind of out there, right? It also has really great discussion questions. So it will ask students to either discuss with each other or to write sentences about why was a number circled versus why was it crossed off. So how come the number 7 never got crossed off? Or how come the number 21 did get crossed off? Okay. This can take a long time. So you can have them work together, partners, table groups, or the whole class together to do this. The first, 5 or 6 prime numbers are not awful, but then when you get to a number like, well, I can't even remember what some of the bigger prime numbers are. 43. So a multiple of 43, I guess, would be 86. But yeah, it would definitely it takes a bit of time. Okay. It starts a whole conversation about prime numbers, not prime numbers, but prime numbers. I will tell you that there are some super cool applications in the real world. So, encryption, and I don't just mean like, spies and secret codes, because that definitely does use prime numbers as well. But just encrypting your ATM card, any sort of electronic data, the encryption uses prime numbers. So there's a couple of cool short videos that you can find on YouTube and different sites that will walk you through that process. I have one linked that is the public key, which is pretty cool. So check it out. All right, that's it. We did it. So we talked about factors. We talked about multiples. We use both of them to develop what the idea of a prime is, and we're calling it a day. Okay, hang in there. My next video will be working with prime factorization. Until then, have a wonderful rest of your day and keep doing math. All right.